thanks everyone, and welcome everyone to today's webinar, collaboration between HiveMQ and FlowFuse, and we're going to talk about UNS today. And Hive, as well as FlowFuse, are core components to a unified namespace. So we'd love to introduce you to the concept today, and yeah, we're very glad that you're here with us today. I'm ZJ van der Weg. I'm the FlowFuse CEO, and I am joined by Kutsai today. Kutsai Mandi Teresa. He is a unified namespace expert at HiveMQ, and he's a senior industry solutions advocate.
Thank you, ZJ, and thank you to FlowFuse for hosting this webinar, where we will discuss and, more importantly, demonstrate, how to power the core components of the unified namespace using FlowFuse, Node-RED, and HiveMQ's MQTT platforms. So, as ZJ has already mentioned, my name is Kutsai Mandi Teresa. I'm a senior industry solutions advocate at HiveMQ, and also am a founder of Industry 4.0 which is also a media and education company focusing on smart manufacturing education. So let us begin by looking at our agenda for this webinar. So first of all, for those of you who are not familiar with FlowFuse or HiveMQ, we're going to take a brief moment to do some quick intro of the respective platforms. And then, so the general theme really for today is about demonstrating how you could leverage, the unified namespace to, digitalize your manufacturing workflow. So a big part of this session is going to be around demonstrating, the concept of the unified namespace. So we've talking about the unified namespace a lot. We've written blog posts both on the HiveMQ and FlowFuse side, talking about this concept of unified namespace. But I think a more, powerful way of really, making really this, stick is to show you what that looks like in practice. So we're going to spend a great deal of time talking about the practical aspects of the unified namespace. But for those of you who may not have heard the term at all, we're going to touch on that a bit just to make sure we're all, on the same page. But what I want to do, first of all, is really spend some time, describing what most traditional manufacturing operations and production management currently look like, and what are the actual challenges that they're facing that could be solved by the unified namespace architecture. And then from there, as I mentioned, we'll briefly go through the benefits of a unified namespace architecture and highlight its core components. And then from there, we're going to then go into detail in discussion about the edge to cloud unified namespace architecture using FlowFuse and HiveMQ. So for those of you who are already thinking about how do I sort of build a unified namespace from scratch, this is the right webinar for you, because we're going to tear it apart, the all unified namespace architecture from the edge to cloud, to show you how that could be achieved using FlowFuse and HiveMQ. And then lastly, we're going to jump into the demo, as I mentioned. So first of all, I'll hand it over to ZJ to give us a brief introduction to FlowFuse.
Yeah, thanks. So FlowFuse is a platform to manage Node-REDs in its most simplest terms. We are a company built around Node-RED, and Node-RED is a core component of the platform, although right now we have more offerings in there. Node-RED can run either on the devices on the right-hand side of the slide, or in the cloud managed by either FlowFuse or on your own hardware. And the core thesis and the core application for Node-RED is to either transform data from digital to digital. So for example, HTTP, you can request data from an MES, an ERP, or some other system, transform the data, rearrange it, combine it with other data sources, and then push it to other systems. And what we see very often on the devices is that it attaches to a machine and extracts data. And this could be retrofitting older machines and extracting the data from those old machines into a digital form, and then push it back through MQTT or other fashions into your architecture. or these devices are on the edge because sensors have to be on the edge. So CO2 monitoring, for example, or other IoT use cases, that's where FlowFuse is applied as well.
Awesome. Okay, so HiveMQ is a platform that is designed for the movement of data from devices and machines on the shop floor into the IT domain, and also facilitate that movement, the movement of messages back to the shop floor from your IT. And at the heart of the platform is a scalable, secure, and reliable MQTT broker that has got clustering technology, which makes sure that it doesn't become a single point of failure. So as you start to see a lot of unified namespace architectures, you start to see that there's this one central hub in the middle. So that could quickly become a single point of failure if you don't have that reliability or high availability for your MQTT platform. So that's what HiveMQ really provides as a platform for the unified namespace. So the platform has a control center that provides you with a quick view of your connection health, and also manage the devices that are connected to your MQTT platform. And additionally, the platform has got integrations that allow you to add things like security. As you may know, MQTT doesn't come with security management built in, so we provide the extensions that allow you to connect your security infrastructure to your MQTT platform, and also integrate data into databases like Databricks or Snowflake and all the databases that you can think of, and then also connect the data to some streaming services like Kafka and so on and so forth, and also provide you an SDK that allows you to build some custom connectors in case the extensions that we have here don't satisfy your needs. You're able to build some custom integrations for yourself. And we've got different ways of deployment. So we've got HiveMQ Cloud, which is a fully managed service, and then also we've got a HiveMQ self managed service that allows you to deploy the platform on premise. Okay, so with that out of the way, let's get into the discussion today. So as I mentioned, I want to spend some time really here to talk about the current state of manufacturing, so that we've got manufacturers here on this call. This may resonate with a lot of you when you kind of look at what it is that Unified Namespace is trying to solve. So as I mentioned, sometimes it may be difficult to really grasp what it is that it solves. But if once we establish the kind of backdrop of exactly this is how manufacturing currently operates, this is how the Unified Namespace helps you sort of solve those problems. So what you're looking at here is a depiction of a common manufacturing value chain, as it were. So basically, a company gets an order from the customers, and then they use an ERP system to plan how they're going to fulfill those orders, and then this plan is broken down into production schedules, which are then handed over to the shop floor for execution of the orders, or rather for manufacturing execution. And for the manufacturing execution, you have got normally this layer, and the goal of this layer is to perform many different functions that include production tracking the production progress, and also tracking the health of the equipment, and also the effectiveness of the equipment, and then so many other functions that are within that layer that could number up to hundreds of different functions. So typically this is where you'd find a lot of software, and also some Excel spreadsheets being used for this specific layer. And then we've got the control domain, where you've got your SCADA systems, your control devices that get instructions from the MES layer, or your manufacturing execution layer, and then they send the instructions down to the sensors, to the PLCs, that then do the actuation to actually make that product, to actually physically get the job done. And then of course, for manufacturers, it's important that they make sure that they utilize the resources that they have to the maximum, right? They want to make sure that their equipment is available for production for as long as possible, so they don't have to buy new equipment, right? When they could actually utilize whatever they have, right? And then they also want to make sure that they're producing the best quality possible, to minimize any rework that may need to be done, which obviously eats into the time that they have within a day to be able to perform the manufacturing. And then obviously from the equipment, they want to make sure that they get the best performance out of the equipment as much as possible. And for that aspect, a lot of manufacturers want to track the overall equipment effectiveness, which is an indicator that gives them, sort of like an indication of exactly how they're doing well, on these, fronts like quality, performance, and also the availability of the equipment. And then when the production is done, stuff gets stored, inventory or warehouse or whatever you have, and then it is shipped. And then that cycle again continues. The customer makes the order. So it's this value chain, right? Now, the reality that, for you to be able to, to execute on this cycle efficiently and, optimally, such that you're able to gain, competitive advantage, or just to make sure that you withstand a lot of disruptions to your supply chain, because as many of you have witnessed over the last few years, we've got this disruption of the supply chain. So now this disruption, one could argue that is now more for like a permanent state of operation. So you want to be able to to withstand any disruption. So for you to be able to do that, you want to be able to make sure that you execute on this cycle as efficiently as possible. Now, a lot of manufacturers are not able to do that because there's this digital gap, between their IT side of the business, which includes your ERP system, and the OT side of the business, where you find your production equipment. As you can see on this chart here, there's that divide rather. So in simple terms here, there is a disconnect between your sort of like high level business planning and the actual day-to-day execution, right? So what this means is that when a customer makes an order, so a work order is generated in the ERP system, and to send it for production, it's either printed out on a piece of paper. Someone has to take that paper down to the shop floor, and then it gets executed, or it could be sent as an email or Excel spreadsheet, as I mentioned earlier on. And then when production is done, again, it's not uncommon that paper is used to collect all these results about the production efficiency, and then that information is again passed manually again back to the business planning. And then also the other issue that makes it difficult for manufacturers to be able to operate more efficiently, or rather digitalize their operations, is this idea that we've got a lot of legacy production systems that in the first place were never really designed for sharing data among each other. So a lot of them have got like proprietary interfaces, and then they've got data formats that are inconsistent within each other. And so what you end up having is these data silos, whether for quality, maintenance, and so on and so forth. So there isn't that information sharing, so there's no visibility across the entire manufacturing operations that then would allow you to be able to optimize how you operate. So again, in short, here what this does is that real-time feedback on machine status, operator actions, quality checks has no way of making back to the IT, to the decision makers, for them to be able to intervene whenever something is going bad, and then they can course correct. So this OT-IT disconnect is the reason why a lot of manufacturers want and must undergo digital transformation if they are to solve all these manufacturing problems that are currently in existence today. Now, with that said, not a lot of all digital transformation approaches are the same. So I've mentioned that a lot of manufacturers want to digitally transform, but for the long time, manufacturers have been going down the path of sticking to the traditional sort of like this ISA 95 functional hierarchy model, which is a tiered approach of data integration, where you've got different layers within your manufacturing environment. So basically what that means is that you can only integrate data sort of like in a sort of like tiered approach. So when you need to integrate data from a PLC, you've got a system integrator that is specializing on that one. For your SCADA, you've got a system integrator, MES, and so on and so forth. So it really takes time to to get data and address all the use cases that you may want to address as a manufacturer. And again, it's a complex web of integrations, because all these platforms or devices within these layers of that hierarchy have got point-to-point proprietary interfaces that you need to set up each time that you want to address a specific use case. So if you want to do OEE today, you need to you need to sort of like set up that connectivity. If you want to do energy monitoring, you need to again repeat the same process. So there's no common sharing, although there's no common sort of like ecosystem where you could just tap off of data, which is basically what the unified namespace does. And what you see in the middle there is sort of like a distributed architecture, which is rather a movement, or sort of like a progression from your tiered approach. And this is basically where you have got sort of like standards like OPC which may be sort of like standardized or rather open interfaces. But if you're using a client server approach, still you end up with those web of connections, or what we call spaghetti architecture, which makes it really not flexible for you to be able to add in some new technologies. Because digital transformation, what it is really is about, so looking at new technologies and adding them into your sort of like existing operations, and then kind of like infusing them into that process. So for you to be able to do that, you need to be able to plug in those technologies seamlessly, and it's currently not possible with these traditional architectures because there's just so much connections to manage. There's just so much complexity involved. If you've got an application that needs to gain context from production, logistic, maintenance, it needs to sort of like establish connectivity directly to all these different domains. So this really creates a web of sort of like interactions that you need to set up. So the unified namespace, again, it is this idea that we need to decouple all of these business domain, all of these control systems, and rather create sort of like a central repository of information whereby all of this information, they just need to connect to that one interface, right? So they don't need to really you don't need to sort of like maintain direct connections to multiple devices. You just need to make your connection to that one interface, and you find this sort of like data structure that has got all of this information that you have available for you to be able to address all of these use cases that you want to be able to address. So again, you're going to see what that looks like in practice if it's not already making sense to some of you. So as I mentioned, we're not going to spend too much time really on the theoretical aspects of unified namespace. Rather, we are going to move more into the practical aspects of it. So again, before we jump into sort of like the architecture and the demo, I want to sort of like reiterate the core components of the unified namespace, right? So again, the first really thing that you want to address as a manufacturer, if you want to sort of like digitalize that value chain, your workflow, you want to have interoperably OT/IT connectivity, right? The way that your OT systems connect to that unified namespace or to that data platform needs to be the same way that your IT connects. The data formats, they need to behave that consistency. So this is where the idea of MQTT comes into play. So if you have got connectivity on the shop floor where you've got like Modbus, OPC or all the other traditional industrial automation protocols, you want to do that conversion into like an interoperably connectivity technology like MQTT. And then once you have done that, you want to then create that contextual hierarchical model. And unified namespace, what it does is that it allows you to create that data structure that represents your organization, which it makes it intuitive for you to find the information that you're looking for. And then this is all event driven. So, right, instead of having this polling mechanism where you've got applications that are reaching down to the shop floor and sending requests, about the status of the equipment, rather the equipment themselves, they actually publish information into that data platform as and when there is that change. So this idea of a report by exception, which actually makes it, sure that, you don't miss any changes, right? Whenever there's a change that is published, and if there's no connectivity at that point, that information is buffered locally. When connectivity is restored, that is sent back up. So there's no chance of you losing any information. And then what that does is that you end up creating a single source of truth, right? So you've got all these business domains, all these systems that are using report by exception or event-driven architecture, pushing information into this central repository or data structure. What that does is that you end up having this single source of truth, right, where you're able to then build your business model around as far as that is concerned, because whatever you are sort of like consuming is the current state of any part of your business operation. So it's not like your tiered approach whereby you basically information moves between layers. It moves from one technology stack to the next. So data integrity is not preserved. So the unified namespace, the idea is to create that single source of truth. So now let's, jump into the architecture, the edge to cloud architecture for those of you who are, sort of like wanting to create a unified namespace for their manufacturing operations. Okay, so what you're looking at here is a unified namespace edge to cloud architecture using FlowFuse and HiveMQ. So again, as I mentioned before, we break this apart. The idea really here is that you want to be able to create that that common data sort of platform that allows you to be able to address all the different use cases that you're going to come up with. So you define your events at once, you send the data up, you semantically structure it, and then from there you simply reuse that data for many different use cases. And the use cases that we're going to be focusing on today in this session is going to be work order management. So as I mentioned initially, this idea that currently for a lot of manufacturers, this idea of sharing work order information, collecting work order progress, this is all manual. This is paper-based. If not, this is actually in spreadsheets where that information can only be consolidated after the end of the shift, actually the fastest you could do it, or at the end of the day, or in some cases, actually at the end of the week, right? So you can only see how effectively you're operating after the fact, right? And you don't want to be able to do that. The idea of a unified namespace is that you want to get real-time insights into your production process so that if anything is going wrong, if quality is going bad, you're able to intervene and course correct right at that moment, right? So the idea for work order management use case here that we're demonstrating is that you want to be able to reach out to your database. So whether it's your ERP database, get all the work orders, and then once the work orders are in sort of like in your Node-RED platform, we then publish those into the MQTT broker that is holding that unified namespace. So as you publish that work order, you're not publishing it in a way that you're sending it to a specific application. So if you look at a traditional way of how this information will be exchanged, you have got an ERP system that is sending information directly to an MES system. So there's this tight coupling. If you remove an MES system and change it to another one, then everything falls apart, right? So there isn't that decoupling. So the idea here is that you publish it into that namespace without really worrying about who needs to consume that information. Whoever needs to consume that information, then they simply subscribe and then they listen in on the orders and then they take whatever actions they need to be able to do. So what you see there is that we've got a Node-RED instance that is at level 3, the Node-RED instance. So typically this one is where you've got your sort of like, if you're within a site, you've got your plant manager or whoever is managing that sort of like operation. They also want to be able to see how equipment are actually, effectively sort of like executing on that work order. So this is where we talk about this idea of OEE. So again, you've got production equipment that is pushing information back up into that unified namespace, and that Node-RED instance is then able to consume that information and then present that information to say, we have pushed the work order into the unified namespace, and this is how effectively we're executing on that. So this is all happening in real time in a digital manner with no movement of paper or information existing in many different spreadsheets. And then on the shop floor, level 2, level 1, we've got another Node-RED instance. So this one typically is responsible for connecting to your production equipment, PLCs, machines, and getting all of this data out that you're then going to be able to publish back into your unified namespace. So again, also this one, you want to be able to present a dashboard. So we've published this work order, but because we've got many sort of like machines on the shop floor, and then this work order typically needs to be executed at many different places. So again, the Node-RED instance that is at plant, level 3 is able to allocate all of these, work orders to say this specific part of the work order needs to be executed on machine 1, this one on machine 2. All of this is stuff that happens digitally. And this is where you also need a dashboard where an operator is able to see what work order has been assigned to me, and then they can select that work order, execute, and then they can send information back to say, this is how many bad quality parts we produced, and then they simply click a button, and that information goes back to the unified namespace. So all of this is digital, is automated. Yes, DJ?
Yeah, a short question about the left-hand side in the middle. There's timescale DB and there's the FlowFuse device agent. And so the question is how that works. Like if you store the values in a time series database, how do you organize your topics in MQTT to facilitate request and response cycles?
So basically what we have right now is that we've got a Node-RED instance that on one hand is performing this transactional access to the database. On the other end is performing this event-driven architecture. So you could be listening in on the timescale DB to whenever a new order is generated. Whenever that new order is generated, you read that work order using SQL transactions, and then publish that work order as an event to the unified namespace. So you've got sort of like that Node-RED instance working as a proxy between your transactional and event processing.
So Node-RED consumes all this data, machine data or otherwise, does the transformation, and as soon as a new value is available, it publishes a new value on the MQTT topic tree. So in this case, on something that ends with /OEE metric, something along those lines.
Yes, 100%. And this will start to, make sense also when we look at the practical demonstration, when you start to visualize where exactly this information is going, right? And sort of like, so this is like a site. So this is a typical setup where you've got an MQTT broker holding a unified namespace. You've got your Node-RED agent at level 3, a device agent rather, and then you've got your Node-RED dashboard at level 2 for providing a dashboard to the operator and also for collecting data from your production equipment. But if you happen to have multiple sites, or rather, if you happen to have multiple areas that you want to be able to sort of like monitor from sort of like an enterprise or a central cloud data center, you could also have another enterprise dashboard in the cloud that is consuming data from an enterprise MQTT broker. So you could have multiple of these MQTT brokers at each site that are aggregating all of this information up to the enterprise level. And this may not be everything, because at an enterprise level, perhaps your management, they don't really care much about the finer details of OEE. They just want to know, can we accept this new order? How much utilization or how much capacity have we got to sort of like take in another order? So that is the information that ends up at the enterprise level, and then more granular information at your sort of like level 3, and even finer information like manual steps about what you need to execute right down to the shop floor. So you've got all these different Node-RED instances and MQTT instances that are sort of like put at different levels of your stack. And then at level 3, obviously here you've got your blind IT, so you may have your MES system, you may have your historian or all the other things that you typically find at that level. And also you've got your SCADA system also at level 2 that is also consuming information off of your sort of like your MQTT, your site broker. Right. Now, the question is that you've got all these Node-RED instances. So how do you actually manage them? So you've got all these Node-RED instances scattered across different devices in the cloud, level 3, right down on the shop floor. This is basically where FlowFuse comes in, right? The idea of a FlowFuse platform to be able to sort of like build, manage, and deploy these Node-RED apps from this central place. So as you can see here, we've got FlowFuse device agent. So basically, each Node-RED instance here is acting as a device agent that gives the FlowFuse platform the capability to be able to manage this. And then this management involves things like your security. How do you manage your security? How do you manage the remote development or deployment? So you may have an IT team that is located in one country, and then you've got Node-RED instances scattered all over the world, but you want the development to be done in one place, so you're able to do the development on the platform and then roll out or deploy remotely to all these different locations from that one place, and do things like version tracking, because currently all of this is being done manually. People are putting sort of like Node-RED flows on a USB stick and moving it into the next and things like that. So this is all done into sort of like version tracking built in, and then also kind of like doing that DevOps pipeline if you want to deploy the same flow to multiple devices for scalability. So that's the whole idea of of this edge to cloud architecture using HiveMQ and FlowFuse. So without further more to do, I think we can jump into the demo to sort of like show in practice what it is that we have been talking about for the past 30 minutes or so. Okay, so for the demo, I'm going to start with the FlowFuse platform. So the FlowFuse platform, as EJ mentioned earlier, so you've got the, this option for deploying it on-prem, or you could use the FlowFuse cloud. So what I'm using here is the FlowFuse cloud platform. So as you can see here, I've got some instances. So there's this hosted instance. So basically what this means, this is a Node-RED instance that is running on the same sort of like cloud platform as FlowFuse. And what I have here is remote instances. So if you remember, we had our sort of like Node-RED instance that is running at level 3, and we had another one that is running at level 1, level 2. So what we have at level 3 here is my Windows PC. So I've got a FlowFuse device agent that I've configured for my Windows PC, which is running some Node-RED instance that is responsible for sort of like collecting your work orders from your SQL database and publishing it into the Unified Namespace. And I've got a Raspberry Pi that is hosting a Node-RED instance also that is on the shop floor for the operator dashboard to be able to visualize all these work orders that are being published from the plant broker. So again, here you could add remote instances as and when you want to do so. So you could provide a name, the type of instance, and then here I've only got one application, but you could have several applications where you could do that, and then you'll get the necessary command line instructions for you to be able to sort of like onboard that device agent. And then from there, here we've also got groups. If you want to group your devices, perhaps you want to sort of like perform a common, sort of like operation into a certain group of devices, you're able to group that, and then you're able to sort of like, as I mentioned again, use your DevOps pipeline for your deployments, right? So here you'll notice if I go into my remote instances here, I've got a Windows PC. So this is my Windows PC. So you can see this is actually running right now, last seen 11 seconds ago. It's currently running. And then this is the version of the device agent that I'm currently running. And then here you see, this is the version history. So basically you could see I've been playing around with this a week ago, 6 days, 5 days ago. And then here you get your audit log. Again, all the stuff that I've been doing here, it's logged. You could see all of that information here. And then you could get also the actual Node-RED logs for that specific instance. And then under settings here, the idea of security management and environment management that I spoke about also earlier. And then there's developer mode. So developer mode is what I want to sort of like talk about here. So here I'm actually in developer mode. So meaning that I'm able to access my Windows, the Node-RED instance that is running on my Windows machine from this cloud platform. So if I go to open editor here, you could see here that I've already, I'm able to access this. So I'm able to basically work on this sort of like editor as if I'm working on the actual device, yet I'm actually accessing this from the cloud platform. So let's go ahead and look at how we're sort of like bringing in those work orders from the SQL database. So again, here, if you could see, I've got a Node-RED flow for managing the work order. It's a simple flow, as you could see, but obviously depending on the complexity of your workflow, all of that could be built in. So here currently I've got a timestamp, which means I'm just, continuously polling the database, but maybe you don't want to do that in a production environment. You want to have like, some conditions of when do you actually reach out to grab that order or to perform that transaction to read an order. And then here I've got a PostgreSQL node, which is what timescale DB is. So basically, this is where I'm actually, performing that actual query to grab all those, work orders from the SQL database. So effectively, you're reaching out to your sort of like your ERP, right? And then grabbing all of these orders that typically you would have to move using a pen and paper. So this, again, is a very simple, select statement. I'm just grabbing everything because I've got like a limited number of orders that I, purposely created for this specific webinar. So I'm just grabbing everything. But maybe, again, here you might want maybe a more complex, sort of like SQL query based on what orders you want to retrieve. So I'm grabbing all of these work orders. Now, the first thing that I'm doing is that first of all, I'm publishing these work orders. So I've actually got 3 work orders that I have in my database, but I'm publishing this into this MQTT topic namespace. So basically under global industries, Munich, production areas, press shop, pressing, press line. So I've got an ERP namespace. So basically I'm holding all of these work orders that are coming from the ERP under the ERP/work order. And then you're going to see shortly what that looks like in the actual MQTT topic namespace. So I'm grabbing all of these work orders for that specific line, and then I'm publishing them into an ERP namespace under that specific line, right? So I've done that. Now, the next thing is to say, so I've got 3 work orders, but now I want to delegate those work orders. So I want work order number 1 to go to machine 1, and I want work order number 2 to go to machine 2, machine 3. So again, maybe this may be a simplistic sort of like use case for you, but the point is you've got sort of like this platform that then allows you to be able to say, okay, now for example here I'm saying I want the first order to go into this specific press station 1. So I'm grabbing this work order from this group of work orders, and then I'm delegating. So I'm assigning this to press station number 1. So you could have a more complex, again, sort of like, logic based on exactly how you want your work orders to be sort of like delegated. So this is all automated workflows, again, sort of like digitalizing the way that you're doing that. So I've sort of like published these work orders currently. As you could see, I'm connected to the MQTT broker. So let's quickly look at what that looks like on our MQTT Explorer. So as you can see, we're currently publishing all of this information. So just, expand this one. So MQTT Explorer, for those of you who are not familiar, is an MQTT client that allows you to connect to an MQTT broker and visualize what data is going through it. So this is what we're doing currently. And we're currently publishing these work orders to this namespace, right? So if you remember, this is the namespace that I had on my Node-RED MQTT node. So I'm publishing data to this line. I've got an ERP namespace where I'm publishing these work orders. So as you could see here, I've got work order number 1, which has got information about, when this plant date, delivery date, required quantities, and things like that. So I've got 3 work orders that are under this ERP namespace for this production line. Now I've further went on to sort of like, make this assignment more granular. So if you come here under press station 1, under MES, so if you remember, this is basically where I am publishing this one specific work order for this specific, machine. So I'm assigning this aspect of the work order. So that's one aspect of it. So now here, let's take a look at what that looks like, on the Raspberry Pi. So remember, the Raspberry Pi is that instance that is running on the shop floor right in front of the operator to be able to visualize all these active work orders that are rather available work orders that are available for them to be able to operate on. So again, here, you come back here, I've got my remote instance. I could go into my Raspberry Pi instance here, and then I could visualize. Again, this is a very simple flow. So this is a very simple flow. Again, I'm subscribing to the unified namespace. So again, I don't really know, right? So the Node-RED instance doesn't really know who is publishing this information. It could be an MES system that is not necessarily Node-RED, but it just needs to subscribe to this, again, information about what are the work orders that are available for me to be executing. So you subscribe that information, and then here we're mapping this information into a table for dashboard 2.0. So dashboard 2.0 again is a Node-RED dashboard sort of like platform that allows you to be able to visualize all of this information. So here I've got a simple dashboard that I've created as far as that is concerned. So as you can see, this is an operator dashboard. So the operator is able to say, well, I'm working on assembly line 1, and then I want to operate on machine 1 currently, and then all of these work orders, they show up. So these are the list of work orders that are available for, or maybe there may be too much work orders to work on, but the idea is that all these work orders, they show up on that dashboard, and the operator is able to just digitally see all of this information and say, this is what we need to produce, work order number, this is the customer, this is the quantity that I need to produce. They select it from here. Again, you have the ability to be able to select. So maybe my dashboard is not as sophisticated as it should be, but you're then able to select to say, I want to work on this order. And then as soon as you select that information, again, you could have a Node-RED flow that triggers that information back to the unified namespace to say, this work order is actually now currently active. So the operator has acknowledged that they're working on it. So as you could see, you could then have this sort of like exchange of information within that one unified namespace, and then they're able to select that information. So if I let's see. So if I go back again to my Node-RED work order management, so we've sort of like moved work orders into the unified namespace. We've presented that information to the operator. The operator is acknowledging the unified namespace, the work order that they're working on. That information is pushed back. So again, as you see, we've digitalized that aspect of it. But now we want to be able to sort of like, monitor the progress of the machine, right? The equipment, the work order, is it going, well or effectively? So again, what we want to do first of all is to sort of like, reach out to the unified namespace to get all of this information that is published by the machines. So if we go back to my unified namespace here, you'll notice here that I've got, so from prestation 1, I've got information, downtime data. So whenever there is a downtime, right, this information is triggered. So again, this information that could go through that Node-RED sort of like dashboard. After a downtime, the operator is presented with the dashboard to say, can you tell us what the reason why this machine was down? What happened? When was the time that resolution, or that it was resolved? And all of this information is captured, right, and into a JSON payload, and then it is published as an event back into the unified namespace. Same applies with the quality data. Whenever there's a defect, again, you're able to use Node-RED to sort of like contextualize, transform that information, and publish it back into the unified namespace. So what I want to show you right now is how the Node-RED instance at level 3 is able to grab that information, persist it into a database, because remember, your unified namespace only gives you your real-time information. But to be able to calculate OEE over an hour or over 30 minutes, you want to have that historical context, right? So you want to be able to persist this information, not only for that hourly average, maybe you want to look at it after a month or after a week, or, and stuff like that. So basically, we are subscribing to this downtime data. So again, we're reaching out to the unified namespace to grab all of this information that is coming from this prestation. So as you could see here, we're subscribing to get that information, and we're storing this information into the database. So basically, I'm getting that JSON payload, and then I'm sort of like mapping it to each specific, column within my SQL database to sort of like persist all of that information already contextualized. It's already been contextualized, from the edge, from the Node-RED instance, and then I simply need to just persist it as my data foundation so that I can use it however I want to do it. So I may not want to use downtime data to just calculate OEE. So I might want to create a detailed twin that gives me a reflection of how often does this machine break, or how often has it broken in the past 2 years or so. So you want to be able to sort of like create that data foundation. So that's the aspect of, getting your machine data from the unified namespace into a database from this Node-RED instance. So again, this is the same thing that I'm doing for defect data, subscribing to get the defect data, and then persisting that information into a database. So once you've done that, because you're consistently doing that, you're consistently collecting all of this information, you've established your Node-RED instances, you've established your workflow, you build your flows. Now you want to be able to calculate in real time. So we spoke about this idea that you want to be able to monitor quality in real time, and like not just at the shop floor, at the IT level, you want to be able, from the business decision, to be able to make decisions based on real-time data. This is how we're running at this moment, right? This moment, this is how many defects we've produced. This is the availability that we have, or this is the capacity that we have right at this moment, right? So again, here you notice that first of all, I'm getting this data. So again, here I'm querying this information, right? So for the sake of this demo, but again, you could have many different conditions for you to be able to query this information. So here I've got a query that I've written here to get the availability data. So again, remember, I'm persisting downtime data. So here I'm getting all of this downtime information, and then I'm aggregating it to say an hour. So basically here I'm creating an hourly OEE calculator. So I want to know at every hour, I want to know what is the result of my OEE calculation. And then I'm doing that calculation, and then I'm, sort of again, performing some transformations on that, whether it's, adjusting the decimal points or, doing the actual availability calculation using that equation, which is basically what this one is, right? So we've got 60 seconds, so we want to calculate what is the availability. I'm doing the same for performance. I'm grabbing performance, cycle data, right? I'm using the OEE equation to do the calculation, and then all of this information is, again, this is a very, crucial aspect of it, is to say, once I've calculated availability, I want to publish it back to the unified namespace. Remember, we spoke about this idea to say we want to, that information, for all you know, could be aggregated up to the enterprise level. So we want to push it back to the unified namespace. We've calculated the availability for this machine, for this site. We're pushing it into so that it's visible across the entire enterprise, right? So we're publishing this information back to the unified namespace, and you will notice that we've got this information. These are the KPIs that we're pushing back to the unified names. We know this is availability that we're currently running on, and this is the quality. So this, by the way, this is all real-time data that is currently happening right now from the simulation that I'm running. But more importantly, we are sort of like presenting this dashboard. We're calculating and presenting this dashboard. So if I go to my Node-RED dashboard, so you could see this is what I'm created using dashboard 2.0. So basically all of this, computation or this connectivity that I have to the database, data transformation, calculating of OEE, and then presenting this information, this dashboard in real time. So we've gone through the full cycle of grabbing data from the, ERP or whatever, sort of like system you have that you've got your work orders, pushing it down into the edge and into the machines. The machines are doing the work order. They're pushing information back to the unified namespace, and we're presenting this dashboard in real time to be able to see this specific machine. Right now, we can see that we're currently running at 76.7 OEE performance. These are the availability metrics that I'm actually looking at, and then you can see here I'm actually, running a night shift. And here you want to be able to also, do some more contextual calculation, by the way, which I'm again calculating here. So the losses, because you're calculating OEE, but also you want to be able to say, okay, from this 76.7 OEE calculation, how much of it is actually caused by, stop losses or downtime? How much of it is actually being caused by, performance losses, or how much of it is being caused by quality losses? So here I could see that quality is really contributing legal to, my OEE. And then from there, I could see that, okay, I need to do something about downtime, because this is what is really contributing a lot to, the OEE, because the ideal OEE is to be at 100%, right? So you could see all of this information, and you could also see the downtime events here. I could see that here we actually have, a downtime that happened, sort of like, it's, well, this is 1907, so this is actually, using a different time zone. So we could see that is information that is coming today. So here you could also see this was a planned downtime. This is information, again, that is collected from that operator, who's actually able to then say, was this planned or was this unplanned? So you've got all this context that allows you to build all of these dashboards and calculate your OEE, and then you can create your trends again to be able to see your OEE against each other. So I want to be able to leave out, some time here for questions. I think we've pretty much covered, the whole sort of like flow of using, edge or building an edge cloud architecture using FlowFuse and HiveMQ, and then, went into the actual Node-RED flows that how exactly we're performing that. So over to you, ZJ.
Yeah, thanks a lot. There's a couple of questions we've handled already, or you handled later in the demo. Thanks for that. One that just came in, I'm reading it as we go. This is a very useful and real-time view of aggregation at each manufacturing level. How do you ensure data integrity within your UNS, and how do you build your UNS architecture from scratch? So how do you get started? How do you begin? And how do you evolve from there?
So I mean, a good way really of starting with the unified namespace is to pick a use case, right? So again, here we've picked a use case that we say we want to digitalize the work order management. So you pick a use case and then kind of like look at your shop floor. What data do you have available for that use case, right? So now do you need that layer to be able to do the conversion? So maybe your devices have got like a Modbus interface. So now you need to have a Node-RED package that is able to convert Modbus to MQTT. So you deploy that and then you get your data out. So the idea is to first of all make all the data that you need available, and then from there start to contextualize all of the data. So you push your raw data and then start to sort of like contextualize it once you have it within the unified namespace.
All right. Thank you. And then there was a question earlier around HiveMQ Edge and how it normalizes and contextualizes and curates the data on the edge, and how it would how you would compare it to Node-RED.
So I mean, these two different tools. So as you may know, really Node-RED is been around for a while, and it's really for more like a low code platform for people who really want to build fully fledged applications. So Node-RED is like it's an open-ended rather platform that allows you to build things however you want to do it. HiveMQ Edge is also a connectivity platform that is built for specifically for connecting to say OPC Modbus and then converting that to MQTT on the other end, right? So it's a HiveMQ is a Edge is a sort of like more a specialized tool to convert that data into your legacy automation or protocols into MQTT, while Node-RED is really a platform, right, for you to build whatever it is that you want to build.
Yeah. All right. Thank you. And then someone likes your flows so much they want a copy of them. Can we make these available async? We haven't discussed pre the demo. We should have seen this question coming because I like this dashboard. But I guess we'll find a way to distribute these. And we'll work with you, Kutsai, on how to deploy it on your own site and how to get your OEE dashboard. Maybe even put this on a TV next to your manager's desks, just to show how well the job is you done.
Oh yeah, absolutely.
Do I need machine state for me to get an accurate OEE calculation?
So machine state is always important, right? Because this is really what gives you an indication of whether you're running or not running, and then from there you need to have reasons for why this machine is starved or this machine is stopped or and things like that. So machine state, I would say, is really important. It's basically it's the most important because indicator that lets you know when you should record or when you should sort of like collect that information about your downtime.
Yeah, fair enough. And then the last question is on how to extract data. In this case, the question is around ERP, but more holistically and zoomed out a bit, like how do you adapt your data, which is not UNS or MQTT native, for the UNS? What connectors to use? Are there best practices? Can you share anything on that?
Yeah. So I mean, it really depends again on what. So for example, if your ERP system, so SQL based, right, and your IT allows you to access that SQL endpoint. So obviously you want to have that SQL connector. So maybe you can only access an HTTP endpoint. Again, you use an HTTP connector. The point is kind of like you need to sort of like do an analysis and assessment of how what sort of connectivity interfaces do I have available. And if you remember, one of the core components of what really this edge to cloud architecture using Node-RED and MQTT, what it's all about is about converting into interoperable protocols. So again, you use that Node-RED package whether it's a HTTP package, SQL package, or if it's a machine, it's an OPC package, convert that information into MQTT so that it's sort of like aligns with the unified namespace standard.
Yeah, I would say the same thing. All right. thanks a lot, everyone, for attending. We've come to the end of this webinar. I do want to thank you to not click leave yet. Kindly wait for us to close the webinar. This will allow us to show you a short survey on if you found this interesting and some other questions. I also want to thank Kutsai. Thanks a lot for the session, for building out the demo and showing how everything works. And then lastly, if you are going to go to Hannover Messe next week, do stop by the HiveMQ booth or FlowFuse and come chat with us. We will also be discussing the UNS there on our booth. This will be on the 1st of April, 11:30. It's not a joke, by the way. We will really have this session, and we will provide free UNSs in a box. So ways to extract data, normalize it, and push it into an MQTT broker. And we'd love to show you how we've implemented this with one of our SI partners at the customer site. Yeah, then last I want to say is thanks a lot for attending. Hope to see you in the future webinars, and have a great day.
Thank you.